Hi science students, welcome back. Today we're going to focus on the groups and the periods in the periodic table. I've drawn a very minimal version of the periodic table here, but we're going to use it as an example to talk about those groups and those periods that we see throughout the table in its extended version. Before we get started, I want you to pause the video and write down everything that you see on my paper. So let's get started. In 1864, Dmitry Mendeleev organized the elements in this table based on the properties of those elements. But today, we organize the periodic table with their atomic number. We know that the atomic number is based on the number of protons in any given element, and we can identify the identity of any element knowing the number of protons. So in today's version of the periodic table, we group our elements based on the number of valence electrons or based on the number of shells that hold those electrons. So let's start with groups. And up here in this space in between, I'm going to write my definition of groups. So I'm going to write groups first. And groups are going to be all of the columns in the table. And I'm going to use red to show groups. So groups are going to be our columns, and I'm going to draw some little arrows down to remind me what direction columns go. So the elements in each group have the same number of valence electrons. When we talked about valence electrons previously, we said that that's the number of electrons in that outermost shell, whether that's the first shell, the second shell, the 15th shell. The valence electrons are going to be how many electrons are in that outermost shell. So if I'm thinking about my groups, I know that my group beneath hydrogen is going to be called group 1, and the reason is because it has one valence electron. So I'm going to write one valence electron above it. And then I'm going to, in parentheses, I'm going to write group 1. So the number of my group represents how many valence electrons are in its outermost ring. So for my next group, group 2 here, with beryllium at the top, I know I'm going to have 2 valence electrons. And I'm going to call this one group 2. My next group, group 3 here with boron at the top, is going to have 3 valence electrons. And so every element in this column has 3 valence electrons in its outermost shell. My next group with carbon and silicon and germanium is going to be group 4 because it has 4 valence electrons. You should be able to see a pattern at this point that we're moving from left to right, we're increasing the number of valence electrons. And by the time we get to the end, we should expect that our valence shell is completely full. So in my next group, group 5, with nitrogen at the top, I'm going to have 5 valence electrons. My next group with oxygen at the top, my oxygen group here, is going to have 6 valence electrons. Group 7 has fluorine at the top. And that leaves us with group 8, our noble gases here. They're a little bit special because of helium. So in the box with helium, I'm going to put a little star, and I'm going to write 2 valence electrons. So we know in our group 8, in our noble gases, every one of these elements has a full valence shell. And helium, because it only has one shell, is still a full shell because it has those 2 electrons in it. It's got a filled up shell. Every other element in this group is going to have 8 valence electrons in its outermost shell. So my group 8 except for helium will have 8 valence electrons. If you need to pause the video, I know that was a lot to write down. If you need to pause the video to get this all down first before we move on, please do so. All right, so we're going to go on to periods now. And I'm going to scoot my paper over a little so I can write on the left-hand side. I'm going to use a different color to more easily distinguish them from each other. So I'm going to use blue for this, and below the table is where I'm going to write my definition. So periods are going to be the rows in the table. So every row is going to have something in common. Try to zoom it in just a little bit. So I'm going to draw some little arrows to remind me what direction rows go, from left to right. And I'll write my little definition right here. So periods are going to have elements with the same number of shells. So I'm going to write the elements in each shell. Excuse me, the elements in each period have the same number of shells. We know that means electron shells. So for each row that I have, I'm going to have the same number of electron shells in my atom. So as I work my way down the periodic table, down a column, I'm going to see that the number of shells changes. So let's start over here on our left, next to where it says hydrogen. So hydrogen and helium, these two, are in the same period as each other, and so they're going to have this in common. Just like with our groups, all of these have that one valence electron in common. Everything in the same column is going to have the number of shells in common. So my hydrogen and helium are going to be in period 1, and I'm going to write it right here next to hydrogen. Period 1. And I'm going to draw a little picture of that. So my little dot is going to be my nucleus. I'm going to have one shell around it. And I'm going to write that just to remind myself what period 1 means. It means there's one electron shell for every element in this row. So hydrogen and helium. So then I'm going to move down to my next row, lithium all the way over to neon. And that's going to be my period 2. So period 2 is going to have, two shells, 4 electrons. So I'm going to draw my nucleus. I'm going to draw my first shell that I know can hold 2 electrons. And then I'm going to draw a second shell that I know can hold up to 8 electrons. So every element in this row has 2 shells, no matter how many electrons they have. So then I'm going to move down to my third period, or my period 3, where sodium is, all the way over to argon. And that's going to be period 3 with 3 shells. So I'll draw that. Here's my nucleus. Here's my first shell, second shell, third shell. And then I bet you can guess what's coming next. The fourth row that we see here, starting with potassium, going all the way over to krypton, is going to be period 4. It's going to have 4 shells. Here's my nucleus, shell 1, shell 2, shell 3, shell 4. And we know that there are more rows beneath these 4 in the periodic table. There's 1, 2, 3 at least more in this individual column here. But for the sake of understanding the difference between groups and periods, I thought 4 was enough. So if we went on to the next below potassium, it would be period 5, followed by period 6, followed by period 7. And each time it's increasing in the number of shells. We know that if it's increasing in the number of shells, it has to be increasing in the number of electrons in those shells. So the 2 trends I want you to notice is that, let me zoom you out a little bit. The 2 trends I want you to notice is that as we move from left to right on the table, we increase the number of valence electrons, the outermost ring. And as we move down the table, we increase the number of shells, which means that we're increasing the number of electrons in those shells. That's everything I have for you today. If you need to pause the video to get any of this down, please do so. If not, have a really great day. Bye-bye.